Hello guys, and welcome back. Today we're going to talk about noise cancelling headphone technology. So how does noise cancelling technology work? Basically what it does is it listens to a noise of any type, external noise from the headphone, and it reproduces an equal waveform that it applies to the noise through the internal circuitry. Why, will you ask? It does this. It is because equal waveforms cancel each other. Equal polarities cancel each other. How it works. In theory, the idea of noise-canceling headphones is quite simple. Once one understands the basics of sound waves, the simplest way to understand the mechanism behind noise-canceling headphones is to imagine a transverse sinusoidal sound wave at a single frequency. The principle of substitution tells us, given an arbitrary number of waves, we can sum them up at the same position in time to obtain a new wave. The simple idea turns out to be the only tool we need to develop the theory behind noise cancelling. Since we want to cancel incoming sound, our goal is to create our own noise that can produce destructive interference with the noise coming from the environment. This is the same idea as above, except this time we have a specific end result in mind. A waveform that it is close to zero amplitude as possible, minimizing the sound intensity we hear. This idea is illustrated in figure 3. It's right there you can see external noise versus created noise, or waveform, or equal waveform within the circuitry, which in turn cancel each other out. Notice that destructive interference occurs when a wave interferes with its exact inverted self. Hence, the design becomes clear. All we need is a way to capture noise from the outside, invert the signal, and now put it in time such that we can match the crest of the original wave form we can match the crest of the original waveform to match the output of the inverted waveform. For this, we require a microphone that can convert the noise outside into the form of an audio signal and circuitry that will convert the signal and output it through the headphones, illustrated in figure 4. So you guys see right here, basically you can see right here the headphones, microphone, listening to the external noise versus sound created by the speaker. And since both equal waveforms are equal, they cancel each other out, and what you will have is a quiet area within the headphone. Why? Because at the same time it listens, it creates a counter waveform or equal waveform, and they cancel each other out, and the result will be almost absolute silence. Circuit breakdown. First thing to notice in figure 5 is that it has two identical circuits parallel to each other. This is because we're dealing with a stereo system, and we must cancel each independently, since the noise at each location is different. The easiest way to understand the circuit is to break it down into sub-circuits and see what each part is doing. We will focus on the configuration of each op-amp in the top half of the circuit, representing one channel. The same applies to other channels shown in the bottom half of the circuit. Looking at the connections in 1C1-A in figure 7, we see an op-amp configured as a preamp of gain 34. The input of this op-amp comes from J1, which is the input jack for microphone. Okay, so J1 is the microphone. It is important to amplify the signal of the microphone, since the incoming signal is extremely weak compared to what we need to drive the headphones. The gain here is about 31 decibels. R4 is simply used to provide acknowledgements. R2 acts as a pull-out resistor for microphone. C2 and C4 acts as a high-pass filter. This is important to amplify the signal. This is important to amplify the signal by such a large amount because the noise will be amplified as well. Now, taking a look at figure 8, which focuses on the op-amp configured as a phase converter. Point 10 in this image corresponds to the top right corner of figure 7. Hence, the output of the preamp is routed through the phase converter. The gain here is 1. Notice that a separate connection of the output from the preamp goes to the same switch as the output of the converter op-amp. The switch S1-A allows us to choose between either the regional amplifier signal or the inverter signal. This is used for testing, debugging, and also provides the additional feature of using noise cancelling as bionic headphones to enhance hearing. R14-A is a potentiometer with an extra resistance of 100 ohms. This essentially acts as a volume control on the incoming signals from the switch. The two sub-components described are essentially all that is needed for the noise-canceling part of the circuit. All that is left is a circuit that can mix this signal in with the audio signal coming out of an MP3 player, such that we can listen to music while simultaneously canceling surrounding noise. The final sub-circuit does precisely this. I also found this website, Audio Technica, that talks about noise canceling technology. So the audio solution question of the week is, how do different active noise canceling headphones work? The answer is, have you looked at noise canceling headphones and wondered, how do they differ? There are many terms used to describe these headphones, such as passive noise canceling versus active noise canceling, or feed forward versus feedback. Audio Technica engineers use different techniques to achieve reduction of unwanted sounds and noises. Let's look at some of the terms in detail. Passive noise cancellation. It's nothing more than material between the outside sound and your ears. Having a tight seal and dense material between the two reduces the level volume of the outside noise. Passive noise cancelling devices are worn for hearing protection in loud environments. On the other hand, active noise cancellation uses electronic and acoustic technology with specific intent to reducing unwanted sound. We previously addressed how active noise cancelling headphones work. However, here is a brief overview. Noise is captured by microphones in the headphones where the DSP, digital signal processor, chipset reverses the polarity of the sound wave by 180 degrees. This out-of-phase noise cancelling signal is produced by the driver along with music or other audio you want to hear. To our ears, noise or unwanted sounds are greatly diminished using this active noise cancelling technique. The graphic below visually demonstrates how the unwanted noise red is captured and how the opposite blueprint of the noise in green is injected into the audio signal. The result is the summing of the two, red and green, together to make a line named call, which to our ears is noise, aka noise cancellation. Let's consider this concept using simple math. If noise is +1, and we add it to the reverse or negative of the noise. Near 1, we get 0 noise. There are 3 different types of active noise cancellation headphones that are regularly used today. They are feed-forward, feedback, and a combination of the two referred as Headphone. The difference between them is when the microphone is used in the signal chain. Feed-forward technology uses an external microphone, which is typically in the outer casing of headphones, or sometimes with wire models on the cable. The unwanted noise is captured externally, processed in the DSP chipset, and finally the headphone driver speaker outputs the correct audio. If you are playing music through the headphones, as well as canceling noise, the level of your desired audio does not need to be loud to overcome the unwanted noise. This is the simplest form of active noise cancellation, as you can see in the following image. Alternatively, feedback optic noise cancelling headphones place the feedback microphone in front of the driver, which changes the way the unwanted sound is processed. If the internal microphone picks up any noise that is not coming out of the driver, the DSP chipset identifies it as unwanted noise and creates a cancel waveform, which is sent back out of the speaker to your ears. This technique requires more processing power, as the DSP is constantly adapting to changes in sound. The best of both worlds comes in the form of hybrid active noise-canceling headphones, which uses both feed-forward and feedback techniques. The DSP uses 2 or more microphones to identify unwanted noise and generates the highest level of noise cancellation. And that is it today for noise-canceling headphone technology. Thank you guys for watching. Please like, share, subscribe, feel free to comment, and I will see you in the next one.